And now we will look at learning the material. In neuroscience, synaptic plasticity is the ability of the connection or synapse between two neurons to change in strength. And it changes in strength in response to either using or not being used. If it's used, the connection strengthens. If not, it weakens. The general idea is that any two cells that are repeatedly active at the same time tend to become associated, with activity in one cell training activity in the other. The phrase cells that fire together wire together shows the effect. This is the physical description of learning. So the evidence of synaptic plasticity shows us that we have physiological evidence that memory has stages. You have the initial encoding, then you have the consolidation, and eventually the long-term storage. The long-term storage is referred to as long-term potentiation. Of course, one of the big considerations is you must decide what types of information you want to keep or move into long-term storage. We'll get into that a little bit later. Now, moving something from short-term to long-term memory requires you to reverse the forgetting curve. The typical forgetting curve for newly learned information, as you can see, shows that after 3 days, everything that's been learned is gone, unless we can reverse the forgetting curve by reviewing. Reviewing and recalling the information is what strengthens those synaptic responses and makes the memory last. But what technique works best for reversing the forgetting curve? What's the best review and recall method we can use? Well, a paper recently published evaluated 10 techniques for improving learning. They looked at keyword mnemonics. They looked at self-explanation, interleaved practice, distributed practice, highlighting and reading and rereading. And they looked at practice testing. If we reviewed it by testing ourselves, they found that was dramatically better than any of the other methods. In fact, there was 50% more retention. So we can reverse the learning curve by reviewing the material at different times. And the best method for doing it is testing ourselves or quizzing ourselves. So we can reverse the learning curve by using recall or review. And when we recall something, we're not studying again. We're not trying to acquire the information. We're trying to review it and recall it. But we need a schedule for doing that, because you saw those reviews were periodic. Spaced retrieval is the most effective way to move something from short-term to long-term memory. Basics of it are, you have the intake, then about 5 minutes later go over the main points. An hour later do the same thing. 3 hours later do the same thing. 6 hours do a review. For the next 2 days, you want to review it 3 times a day for the second and third days. By then, you've moved it to long-term memory. The timing on this doesn't have to be exact. Fit it to your schedule, the demands of your life. You'll also find what schedule fits you best. But as you can see, it's a fairly immediate review and then expanding it gradually further and further. If you want a quick way to remember it, think of 5 minutes, 1 hour, 3 hours, 6 hours, and 3 times a day for 2 days. 5, 1, 3, 6, and 3 for 2. And here's where the Cornell note-taking system we were suggesting comes in handy, because you can take in the information, then in the left column do your cues. That's where you're going to test yourself to see how well you recall the information. And then down at the bottom you can summarize or put anything that you think A is important to learn, or you could use it where you're having trouble. Again, it's a method of taking control of your learning procedures. That's why we recommend the note-taking system, because it lends itself to the testing methodology. So we've seen how we can use spaced retrieval to reverse that forgetting curve. We've seen how we can move from short-term to long-term memory. But there's another level of learning we've got to get to. You've got to understand material rather than just remember it. And that requires deep processing. And it requires metacognition. Metacognition is where the learner is aware of what they really know. The learner is not fooling him or herself anymore. They really know they know it. Well, how do you get deep processing? It involves elaboration. You want to learn the material so that you see how the concept is related to other concepts. See associations and relationships. And on the other hand, you want to be aware of the distinctiveness. What sets this concept apart from other concepts? Where are there differences? And it strengthens it if you can make some level of it personal. If you can relate this to your personal experience and understanding. One of the ways you can practice reaching this deep processing level of metacognition is to overlearn. Choose some material coming up on a test and absolutely own it. You want to have all that information at hand for the test. You want to look forward to that test and absolutely destroy it. And one of the things that we're trying to achieve is automaticity. Now that's the process that you're going through is so practiced that it becomes automatic. You really don't have to give it any conscious thought. If you practice the overlearning and the deep processing, it passes on to your study skills and your learning becomes an automatic, easy process. That's where school gets easy.